Modeling with algebra, this is the part of math that we don't really like because this is where we mix math with word problems, and we tend not to like word problems because they're difficult and it's hard to understand what exactly it's asking for. But it really is the most important part of algebra because this is how we use algebra in the real world. So it is necessary, a necessary evil. So let's look at my first example here. This says Jalen's cost C to produce and bake X number of cakes is C equals 130 plus 28X. So she's using this equation to model her cost of baking these cakes. And then she sells cakes wholesale for $33 each, which means that the equation for revenue would be R equals 33X. So it's just $33 each, so 33 times the number of cakes. So we're going to determine how many cakes does the company have to sell to break even. So we're going to start off first just by writing this in an algebraic format. How can we represent this scenario in an algebraic format? So basically, let's just use a little bit of logic here. We know that the cost is going to be this much. The revenue would be this much. We want our revenue to be more than the cost, or else we're going to go out of business, right? So let's start by writing this expression for the cost, 130 plus 28x. That's going to be the cost of the cake. And I want the revenue to be more than that, 33x. So we want to make more money than we're spending. Otherwise, this cake business is not going to last very long. So that's kind of the hard part here, is just the first step. Setting up the inequality. Even though this is kind of a simple inequality, it could be easy to make a mistake here on the first step. So once I have this set up, I'm really just trying to solve for x. If we look ahead at part B, Jalen must produce and sell how many cakes, x number of cakes to break even. So we're just going to solve this inequality, right? The first thing I can do is I could subtract. Let's go ahead and subtract this 28x over to the other side, right? To cancel these out, we're going to move that over. So 33x minus 28x, there we go. That's going to give us 5x. So just bringing down the less than symbol. I'm also going to bring down the 130, anything that we don't change. From here, the last step, just to get rid of this 5, the 5 is multiplying the x, so I'm just going to divide out that 5 from both sides. All right, so 130 divided by 5, that's going to give us 26. Here, these 5s cancel. Bring down that less than sign, and x must be greater than 26. So what does this mean? This means that as long as we're selling more than 26 cakes, as long as x is greater than 26, we're going to make a profit in this business. So Jalen must produce and sell at least 26 cakes to break even. More than that, 27, 28, and you're going to start to make a profit. My next example here, this is kind of just examining our reasoning, or examining how we think logically through a problem. So I'm asking you to justify these following steps to solve this equation. So you probably already know how to solve this equation, and the steps to solve it are already here. But I'm asking you to examine your reasoning here. I'm asking you to justify what the steps are. So this is kind of like a proof. If you remember doing proofs maybe last year or in your 9th grade class, it's kind of like that. So the first statement here that we were given was actually given up here. So the reason for that really is just given. This was given to us in the problem. So really this should always be, even if you're doing like a proof or something, given should always be your first step, unless you have kind of a weird problem. Should pretty much always be this. Next, let's just look at what we changed here. So the difference from this first statement to the second statement, it looks like we distributed this 2 through the parentheses. So we got 10x 2 times negative 2 is negative 4. So that is really just the distributive property. What happened next in the third step? So I'm kind of always looking a step backwards to see what changed. So to get this reason, I looked back at this statement to see what changed here to the second statement, and same thing for the next one. So to see what changed in the third statement, it looks like we just brought down the 10x, and then what changed? This negative 4 and this minus 36, we just combine these together to get a negative 40. So this step is just called combine like terms for that third step, that third reason. On the next one, so let's just see what changed from step 3 to step 4. Here it looks like all we really did was we just subtracted this 3x. So we did 3x minus 3x to this side to get all of our x's together there. And that's all we really changed. That's called the subtraction property, or you could say the subtraction property of equality. All right, as we get towards the end here, it starts getting a little bit easier to see the changes. The next change here, so we had a minus 40 here. It looks like we added 40 to both sides, plus 40, to get that 42 down here. So this is just the addition property of equality. We added 40 to both sides. And the last step, so I'm just kind of looking again back at what happened from the previous statement to the last statement. This was a 7x, so to get rid of that 7, we just divided both sides by 7. That is called the division property of equality. All right. So that's basically here. With examining our reasoning, we're just looking at kind of what's the difference between these two steps, these two statements, and just see if you can analyze, tell what happened is all.